Clear, right? And also, okay, so close the Kubernetes sessions. 2, 3 are pending. How many days? How many classes done on Kubernetes? Huh? 13. Kubernetes architecture also class only. Oh, anyway, please focus here. School books తిరిగేస్తున్నారు. kubectl get nodes. Okay. How many nodes are running? 2 nodes are running. So guys, in the project, my image is calling from ECR and deployed into the cluster. So guys, a simple logic here. If my pod deleted, for example, new pod will create from the same image, right? Any data will be lost? No. The image contains application, no data will be lost. But same process, the same pod is the combination of database. Understand, like a container, right? We already discussed Debian container. Already you guys done project also, right? Debian EC2. Sorry, MySQL and container. Already you have done project, right? Docker Compose temp. Front end container, back end container, MySQL container. So their volumes are mandatory for which layer? Front end, back end database. Which layer volumes are mandatory? DB. Why? Data will be stored in the DB. If DB container, so we have given a host path volume, right, at that time. In the container Docker concept time, we have created a host path volume. Even the container deleted, new container will created, it will take a same volume from the on EC2 instance. The same concepts we are going to discuss here also. But volumes are mandatory for what? Database applications. The database applications are stateful sets in the Kubernetes. I mean, if you are working, if you want to work with MySQL, PostgreSQL, MongoDB, MariaDB, all are on pods available. So those are stateful sets. That means if the pod deleted, again new pod will create. It doesn't matter on the stateless application, it will take a new same image. But stateful set, definitely we have to take care. If the pod deleted, same pod will create with same volume also. Right or not? For example, I have updated 1 GB data. Pod deleted, 1 GB data will be lost or not? If the pod is created with the new pod, what about 1 GB data? We need a data also, right? So the concept of stateful sets are a very important for the interview point of view. The stateful sets means a database applications. So we need a volumes. Volumes are mandatory for database applications. Okay. Let's draw the one architecture you can understand. So this is my cluster. For example, my 3 nodes are there. I'm taking for 3 nodes. So let's say my pod is running in this node. One pod is running in this node. One pod is running in this node. And one pod is running in this node. Clear? So అందరికి హెడ్స్ ఉన్నాయండి. Even you can use my deployment.yml or stateful set.yml. We know, right, when we can use the stateful set if the pods are. So this volume, for example, is 16 GB. Understand? Node volume. Is it possible to create a 6 GB client? No. PV only 5 GB available. So we can't create a client 6 GB. Till 5 GB it is okay. So pod can use 6 GB, 5 GB till. install git-y. Okay, so let's take the clone command. Mm, okay, let's clone this still here. Yeah, thanks. Okay, so go to volumes, date and so we have a I'm going to talk about static host path, right? Host path volume this. Then we can go for EBS, dynamic volume provision. We have a two type of volume provision, static and dynamic. So let's go for static is on host path, dynamic on EBS volume provision. Okay, so as I discussed, we have a pv.ml, pvc.ml, deployment.ml. Let's say first we can focus on pv.ml. So creating a persistent volume, the metadata name, this is just name only, these are the labels only. Storage class name is manual, capacity storage is 5 GB, access mode read write once, host path is MNT data. Means 5 GB PV volume is creating on MNT data path on the node. Okay, so that MNT data path inside the volume will be stored of your pod. Okay, in the node inside only. So node inside which path will create MNT data? How much volume it can use? 5 GB. Okay, yeah. So I'll explain what is storage, read, write, and once and all. Wait, let's take from here. Okay, next I'm creating a PV. This 5 GB volume taking from where? From here only. Clear now? Okay. So this pod is ready. For example, this pod is created here only again. Okay, anyway, I'm not copying from here. This is already been this process we know. I'm taking a deployment.ml, metadata name is MySQL, it's a selector, strategies recreate. Okay, specification is what? I'm taking MySQL. So these and all we know, right? Environment variable password, port number. Okay, I'm just taking from here. Okay. So by default, pod volume will MySQL. I mean, MySQL host is running varlib MySQL. Which PV it will take? If I create a one more PV, so let's say if I create a one more PV, same kind of PV, here one more. So PVC will take which PV? Hmm? Okay, let's say if I create one more PVC name I'm giving a different name, right? Same name not accept, right? Different name. My deployment will take which PVC? First one only. Why name? Same name I'm giving here. Right or not? Okay, this is cool. Next, PV to PVC. My end two PVs are there. So how PV PVC will communicate? I'm saying based on access mode and storage. I'm saying that, right? So definitely these two make and repeat, right, for different PV also. Definitely I can create a one more PV. That PV also I can give same storage. That PV also can give same access mode. In this case, PVC will call which PV? That's what my question is. Tell me. So two PVs are there, right? PVC will call which PV? Huh? Tell me which PV? Any PV, right? Is there any problem? I need a 5 GB, that's it only. Any PV is fine or not? Why PVs inside no volume constraint, any name constraints are not there. So definitely my PVC can call any PV. Okay, let's say this PV called by this PVC. Now what is the status of this PV? Free or bound? Bound. Now one more PVC for different deployment. One more PVC, one more deployment. Tell me now, which PV this PVC will take? Whatever PV is available only, right? So why this is already bound, this is unbound. So it will take no conflicts, right? Why? Volume already busy means no other deployment can call. Even EBS volumes. If EBS volume already attached, we cannot attach the same volume to different instance until you detach. Yes. Same concept here also. Okay. Okay. Perfect. Yeah. LS. So let's deploy now kubectl apply -f dot. So kubectl get pods. Container is creating. Very important point. Understand now. I'm going to discuss now. Pod is running. Guys, now tell me kubectl get pods -o wide. Yeah. So my pod is running on one node. Okay. So let's log in a pod. How to log in a pod? Hmm. inside of the pod. So how to log in client again? I'm inside of the pod just where the MySQL is running. Same, if the MySQL is running on EC2, you can log in EC2 first, then log in a MySQL client, right? How to log in MySQL client? MySQL-h. So in this case, let's go and check the env variables of database. Root password. Password is password, means username is what? Root. MySQL-u root -p. So password also password only. You are instead of MySQL pod now inside the client. So create a database test. Sorry. Database created, right? Show databases. Use test. So let's create a sample table here. Yeah, I'm creating a sample table here. Somewhere you can add and test dot cut. Okay, table also created. Tell me guys, this table, the table created means this data will be stored on where? Huh? Node. Node. Inside the node where? Volume of the node. And which path? MNT data. Hello? Okay. So guys, this information stored on where? Hmm? Node. Now the question is which node? We have two nodes, right? On which node? Huh? Which node? Which node? So definitely where the pod has schedule, there only it will be create. So let's say go to the nodes. So let's check running nodes. We have two nodes. You can see now. So let's go and check kubectl get nodes hyphen wide. Yeah. So now if you can see here 192 168 49 82. Not this one. Wait. This one, right? Pod IP. Let's connect this node. Yeah. So what is the path? What's my database name? Test. My table name is what? Persons, right? Cat. So VI, so the data, it's a encrypted format, right? We are unable to read this. Clear now? Let's go for other node also. CDMND. See, no data is there. Clear now? This node inside, no volume has created. Till here clear now? What I am going to do now? kubectl get pods. kubectl delete pod. Copy. Again pod will create or not automatically? Create. Running right 6 seconds ago. -o y. Okay. So my pod has created a different IP now. So kubectl get nodes -o y. Okay. So let's understand now. This time my pod is running on which node? 3 to 35. Before also same? Before also same. Okay. Let's you can see pod name is changing, right? Because of deployment.yaml. Okay, this time same okay. So now okay, this is cool. If pod is created on same node, you can access the same data. If pod is created on different node, are you able to see same database? Are you able to see same table? No, right? If pod create on this node only, we can see the information. For example, my deployment.yaml, if I give a replicas, a 1 or 2, what will happen if I create a replicas 1 or 2? So definitely if I give 1 or 2, one pod can create on one node, one pod create on one node. So first pod may be master, second pod may be reader. So if read pod delete and create master place, what will happen? Master delete on the node and create a read node. Definitely different volumes will be there, right? Read different volume, master different volume, completely out of sync. Clear here? So read pod deleted on second node, read pod again create on second node. Master pod deleted on first node, again master pod can create on same node. This should be take care, right or not? So if the pod delete and create a different pod, definitely the volume will be lost. Or we need to create a node selector options to create a pod on same node only where the volume already exists. You can write a conditions. Clear? But this is not recommended. We can't control, right? Even node deleted also volume deleted. So many things are there. So this is not recommended. So last time we can try. can schedule on same node. So if it is scheduled on same node, no problem. We can access, but we don't have any guarantee, right? The pod can schedule on any node later. So in this case, volume are stored, and again if pod create a different node now, again what will happen? New path will create, and second node also empty data. First node inside empty data is there, second node also empty data is there. But second node fresh pod, first node already database exists, table exists. So completely out of sync your MySQL. So that's what host path has not recommended. Only go for additional volumes. Clear till here, everyone? Okay. So static path has not recommended as we don't have high availability. Simple answer. If node deleted, volume deleted. Even pod create and different node, same volume not exist. That's it. 2 points only. Okay. kubectl delete -f dot. Oh, let's apply again. I forget to show you volume set. Okay, now you can check kubectl get pods. What has running? Kubectl get PV. We can check the PV, right? So bound status. Now this PV, any PVC can use? No, already it's a bound. Kubectl get PVC. We can describe also. So PVC also bound on where? MySQL PV. MySQL PV means what here? This one. So PVC bound on this PV and PVC can bound on this deployment. Clear, right? Okay. The next concept is same static host path we can do and cloud EBS volume also. So that you can try. I will give a guidance how to do. Just very simple step only. Static cloud path means first you can create a one EBS volume manually and give the volume ID into the PV. PV creates volume from where EBS volume before, right? That EBS volume is already attached to node. So before case, I'm creating a PV from where? Self node volume. But now create a one PV. Create a one volume inside the instance. Here like this. I'm creating a volume directly. Once volume created now, you can see here volume, right? Take the volume ID and give here. That means PV creates from additional volume. Until you delete a volume, PV will not delete. Same. Use PVC. Same. Use deployment.yaml. Same concept. But the difference only PV. Static cloud path, static node path. Static node path, PV creating from the same node volume. Static cloud path create a volume. The volume is not attached to any node before. So that node delete also volume is not delete, right? The volume is additional volume, not interlinked to any node. Like that also we can do. But this is the recommended way, dynamic volume provision. This is important one compared to all. Okay. So here I'm using stateful set. I will tell you why. Stateful sets here replicas are 3. But before case replica is 1. That's what I'm using a deployment.yaml. When the replica is 3, I should use stateful set. Clear or not? This name I need to change to stateful set actually, not deployment.yaml. sfs.yaml. So now this is little difficult. Focus. Dynamic volume provision. So automatically pod will create a additional EBS volume. So guys, my pod has to create a EBS volume. First, my pod should have access right to create EBS volume, right? So in this case, my pod running inside the node, whatever role attached to the node should have a EBS access. So that pod can connect to node and node can connect to the specific permissions. Okay. In this case, what we can do? First, two things we need to understand here. Okay, the first one permission, second one communication. So the communication purpose, first open EKS. Okay, this is my cluster. Two things we need to understand. First one is permission, next one is connection. So in 1.30 before the cluster version, we have to install the drive, EBS drive. Now we no need to install any drives. Simply add an option is there. Click on this add an option. Already metrics are also there. See, 1.3 below versions, metrics are not there. We have to install manually. So now metrics, kubectl top horizontal pod auto scaling time concept and we discussed it. Kubectl top pod top node, we can see the node CPU, pod CPU and all. At that time, metric server haven't installed because of it's a 1.3 version. By default, metric server is inbuilt. If it is not there, we have to install. So add-on option is there, right? Get more add-on. You can see here, I can configure CloudWatch logs also directly. I can configure EBS ESA drive also. So my cluster will communicate now EBS drive. Add-on, after add that, next. So first path has created cluster to EBS. Next we should have a what? Permissions, right? For the permissions, we have to go for node group. This is the node group. Open the node group. Here you can check the node group role ARN. This is the role ARN. You can take from this area. Copy. So go to IAM role. So node group ARN role already created along with the cluster. That role we can attach a EBS permissions. So attach policies. You can give EC to full access. So EBS also will get it. Okay, done. So yeah. So now you can go for the dynamic volume provision. Whenever you can use the dynamic volume provision, PV AML is there, right? Here VI storage class.aml. If you can see, this is the AML file. Okay. So my storage class.aml. See, provisioner is what here? Using EBS ESA driver and create a volume inside the EBS. When the storage class.aml initiate to create a EBS volume, here you can see two type of policies are there. Immediate, volume bind mode, wait for first consumer. Okay, if you can see, immediate means what? Whenever I can create a storage class.aml, immediately it will be created. Volume bind mode, wait for first consumer means what? Irrespective of deployment is ready, only volume will be created. So when I create a deployment.aml or stateful set.aml, if I apply, only the request will go to and create a volume inside the EBS. Clear? The two things. Wait for first consumer means if I'm ready to consume only, volume will be created. Until and that, volume is not created. Immediate means whether consumer is there or not, volume will be created. Pod create or not, volume will be created. So in this case, let's go for the story class.yaml. Story class.yaml, deployment.yaml, both are same. The difference is kind only. All are same. You can see env variables for database, volume mount by default volume path is what varlib mysql for the mysql, and now volume climb template. So now if you can see this volume climb template now, so you can write volume climb template separately. Volume climb template means what? Climb the volume from the story class. Next, this template use to provide a volume to your pod, right? So if I create a stateful set, how many pods when create depends on the replica, right? Let's say my stateful set created 3 pods or 2 pods. Clear now? How the system will work, you know? This PV storage class when I apply, one PV will create background. How many PVs you can create, you know, depends on the replicas. PVCs depends on the replicas. Pods depends on the replicas. That means your stateful set create a separate volumes for separate pods. Clear what I'm trying to say? So in this case, this pod PVC separate, this pod PV separate, this pod PVC separate, this pod PV separate. If this pod deleted na, create same pod with the same name place, same volume also attached. If it is deleted, same name with same volume also attached automatically. Clear the concept now? Let me show you practically. So PVC, I have updated inside the YAML file deployment. You can write separately this. You can call the PVC name here. Like before we already called, right? I'm calling MySQL persistent storage PVC client. In that case, you can create a separately PVC. Now what I'm going to do, directly PVC I'm adding into the deployment.yaml. You can do anything separately we can do, or you can add inside only. Okay, so kubectl container is creating your volume PVC. First container is not creating it. For example, if it will go for pending state na, the meaning is volume is not ready. Volume is mandatory. If volume is not ready, pod is not deployed. How many pods can create now? If you can see, it's a stateful set, right? That's what naming conversion. If you can see MySQL 0, MySQL 1, MySQL 2, sequence wise, it will create a name, and it will apply for stickiness for the name. If 0 will delete, 0 will create. 1 will delete, 1 will create only. I'll show you. See, after create 0 only 1 created. After create 1 only 2 started. It's a sequence process. So by default, 0 is a master. 1, 2 are replicas. 0 always master by default in the Kubernetes. Consider it's a consider identity. 0 always master. 0 is there, 1 is there, 2 is there, right? Now tell me guys, how many volumes may be created? volumes created, 3 volumes bound. Now this volume bound on where? 0. This volume bound on 2. This volume bound on 1. Let's go and check volumes now. Refresh. See, you can apply filter size is equal to 1 GB. Clear. Dynamic PVC, dynamic PVC, dynamic PVC in use. Clear. So now tell me, if cluster delete, volume will be delete? No. Even cluster also delete, this volume is persistent. Additional volume. No delete, any volume will be deleted? No. The thing is, the final validation is kubectl delete delete pod a MySQL 0. Now tell me guys, MySQL 0 delete means which pod will create again? 0 only creating, name also same, right? But deployment data is not like that, right? Different name will be, but same MySQL 0 will create. So why volume identification also? Volume already identified with the MySQL 0. So same volume will be attached. Let's go and check same volume will be attached or not. Kubectl get PVC. You can see 03EB 03EB MySQL 0 before. After delete also you can create 03EB. Clear. Master volume separate, read volume separate, all are separate now. If my pod deleted, automatically create on same volume or not? Because of stateful set. Stateful set give a separate volumes for separate pods. 0 delete, 0 will create. 1 delete, 1 will be created. 2 delete, 2 will be created. Do I need to worry my pod has running on which node? No. Why? I'm not using node volume. Separate volume. Separate volume means your pod can access a separate volume. Doesn't matter the volume is attached to any node. Anyway, these volumes are not attached to any node additionally. Clear. Pods only using these volumes. Okay. The same concept. Okay. The same concept you can see. We can do one more process also. Can anyone say that? Instead of attaching EBS CSA driver, instead of giving node full access, node role we are giving full access, right? EC to full access. Instead of using node role, we can do the same process one more way. Anyone? Huh? RDA. Sorry. Database is RDS. No, my question is to access my pod to EBS volume. What I did, EBS CSA driver attached for connection. Next is what? Given permission for my role. Role means node group role. Same role created for all nodes, right? So role, I have opened the role, I have given a EC to full access to role. Now tell me, my node inside every pod can communicate or not? Every pod able to communicate EBS or not? Why? Node level permissions given. But I don't want to give node level permissions. Then, very good. Service account. Service account for permissions. What about CSA driver connection? OpenID connect. OIDC. OpenID connect for communication connect path. Service account for permissions. Clear na? Yeah. So S3 access. My pod how able to access S3 at the time? I have shown you two ways, right? Given full permission to node level, I'm able to access. And second is what? service account, create an OpenID Connect. Instead of accessing through node role, we are bypassing by using OpenID Connect and giving a service account level IAM policy and connected. Same, we can do the same process. kubectl delete deleted stateful set and all. Now you can check still volumes are there or not. Stateful set deleted, still volumes are there because of persistent additional volumes. So this volume I can attach to any node also later, right? So we have a many ways. So again we can take these volumes by taking a snapshots also, right? So we have a many ways. Clear till here? Okay, now your task is today, MySQL 0 is there, right? Log in a MySQL 0 pod and update the records. Same records will update or read replica or not, you can check. Clear the concept what I'm saying? In RDS, master read replica concept is there, right? If you do changes master, same data will be updated in read replica, right? It's a sync, right? Now same process you can do. MySQL 0, MySQL 1. No need to go for 2. You can take one read replica, one master. Do the change, update the records in the master. Same records are updating or not in the read, you can see, and let me know today. If not updating, how to enable this process? If I create a table, say, if I update, if I insert the records, same records will be inserted into MySQL 1. How to do? Same like RDS. Clear the concept? Okay.